I'm not even in it.
All right, hi guys. We're here today at Oak on the last day before the school is closed for good. I have some special guests with us. We have Miss Ho, we have Mr. Sherman, we have Miss Joe visiting us, and we also have Mr. Loomis. We have none other than the Voyager math teacher, Mr. Howard. Mr. Howard, please say hi to everybody.
Hi, everybody.
We also have Mr. Smith back there. And look, special guest, Mr. David Steinkamp, tuning in for our YouTube channel. Miss Raina is also there too for our You Explorers back there. Alright guys, so I'm going to go ahead and give you some notes for our next chapter, which is chapter 10. The focus of chapter 10 is going to be quadratics. And we had actually seen this, so that's what we're working on chapter 9. So the focus of this is going to be 10.1 through 10.3. And again, what we're going to be doing is we're going to be graphing our quadratics. All right, so if you guys remember, what makes a quadratic unique is that it's going to have a squared term on it. So we're going to see equations that take on this form. Y is equal to ax squared plus bx plus c. And you guys have seen this before. This is what we were factoring, so those three terms. And again, what makes this unique is that we have that squared term. Okay, if you guys remember, a quadratic takes on the shape of a parabola. So parabola being that U shape. So we know that if we were to graph something like this, we would get a graph that might look maybe like this. All right, and so today what we're going to talk about is how we graph that. The first thing that you're going to need to know to graph any equation is actually where to start it. Because we want to get that U shape, what we're looking for is actually that centered point, or where's the middle of this graph. And so how we do that is by finding what's called the vertex and the axis of symmetry. So again, the axis of symmetry is going to be kind of this line that cuts that graph in the middle. And the vertex is going to be either that lowest point or that highest point. And again, that's just going to help us figure out where to start. That's going to give us the center so that we can kind of work our way outwards. All right, this is what you need to know. So the axis of symmetry is going to be found by using the formula x is equal to negative b over 2a. Once we get that, that's going to help us find our vertex. So I'm going to go ahead and show you guys an example of what this would look like if we were to graph it. All right, so let's go ahead and start with an example of what it would look like to graph a quadratic. So let's say our example here is y is equal to negative 1/2 x squared plus 2x plus 3. All right, so again, we know this is a quadratic because there's that squared term. Where we would want to start, again, is going to be that axis of symmetry. So again, axis of symmetry. And I'll go ahead and abbreviate that. And again, what this is finding is just where is that center of the graph for us. And again, how you find that is we're going to use x is equal to negative b over 2a. And again, those variables refer to just your terms. So a being your first term, b being the second term, and then c being that third term. So as we plug this in, what this looks like is x is equal to negative. So you want to keep that negative there on that b. The value of b here is 2. And then we're going to put this over 2 times a. And a in this case is this negative 1/2. All right, simplify that down. What you end up getting is x is equal to negative 2 over negative 1. Which in this case will simplify down just to a positive 2. All right, and so let's go ahead and talk about what this looks like if we were to graph it. So I'll go ahead and put a graph here for us. There you go. All right, so x equals negative 2, if you guys remember, is going to be a vertical line, so going up and down, so x is always 2. And so that would look something like this. And so again, what this is the axis of symmetry. It's the middle point of the graph. If you were to kind of fold that paper in half there, it would mirror each other on both sides. All right, from there, it's our favorite thing. We would have to set up a table for this. I'll go ahead and put this right here for us. So just an X and Y table. Again, what you want to use is that 2 that we just found. That's going to be your center point here. So going from 2, I would go up, probably pick 3 and 4. And then I'd also go down and pick probably 1 and 0 for that table. And then what you're doing again is you're just going to take those numbers just like we normally do, and you're going to plug it back into that equation that we have here. Figure out what are those y values. So for example, 0 being the easiest. Negative 1/2 times 0 squared is 0. Plus 2 times 0 is still 0. And then plus 3 is 3. And so you would go ahead and you would calculate those values. All right, for sake of time, I'll go ahead and fill those in. You would get 4.5 here. 5, 4.5, and then 3. And you should notice that the numbers actually will mirror each other most of the time. So when I go ahead and plot that, 0, 3 is going to be right here. 1 and 4.5 is here. 2 and 5 is here. 3 and 4.5 here. And then 4 and 3 is going to be right here. And what you guys should notice is you got to get that curve again. So again, this kind of curve shape here and this curve shape here. And like I said, you get that parabola. So last thing I'm going to point out about this example is remember that axis of symmetry that we started at, that 0.25? Notice here it's the highest point. So this again is what's called your vertex point. And that's what we're looking for as we graph a parabola. Again, that's the center point of our graph, so that's what you're going to be looking for. All right, let's talk about a couple other things that are going to be significant with our graphs, though. Notice this graph started with a negative sign in the front, and that's going to be represented by that sad parabola. So again, negative. Again, indicates just that sad face parabola. So that's one thing you might notice. Versus if we had a positive graph, we're going to have more of that happy face parabola, maybe something like that. So again, watch out for that. Let's take a look at one more example. Let's say we have a term like this time. Y is equal to x squared minus 4. All right, so a couple of things that we can notice. So one, again, we're going to know it's that parabola shape because it is a quadratic. You'll notice also on this graph that our leading coefficient is this 1 or this positive 1, so it is going to be opening upwards. All right, with this equation though, what I do want to point out though is you actually are missing that middle term. You can think of this as y is equal to x squared plus, let's say, 0x minus 4, since there's really nothing in the middle. But that might help some of you figure out, again, that we have that a term, b term in this case would be 0, and then c to help us figure out that axis of symmetry. So again, in this case, first thing we want to find is axis of symmetry, that center point. So x is equal to negative b over 2a. So in this case, x would be equal to negative 0 over 2 times 1. We would get x is equal to 0 over 2, which is the same thing as 0. So 0 here being our axis of symmetry. All right, and so if we were to graph something like this, let me make this a little bit bigger. 0 here being this y-axis here. This is our center point then. All right, and then remember from here what's happening is we're just going to go ahead and we're going to make our table. Again, we want to take our center point, that's 0, put it right in the middle, and then go either up and down from there. So 0, I'd go 1 and 2, and then I'd go the opposite way, negative 1 and negative 2. And again, same idea, you're going to plug in those numbers into that equation here. So y is equal to x squared minus 4. And then that's how we'll start getting these numbers. So for example, 0 squared minus 4 would be negative 4. You guys would calculate that. 1 squared minus 4, negative 3. And then 2 squared minus 4 would be 0. And again, same thing with the other numbers. Like I said, typically what happens, you'll notice that it mirrors each other. But again, just in case you're not using that even interval, you might want to plug in those numbers though as well, just to verify. So again, when I graph this, negative 2 zeros here, -1, -3 here, 0, -4 here, 1, -3 right here, and then 2, 0 right here. And so again, what's happening is you kind of get this U-shaped parabola. And again, you'll notice that it is opening upwards. All right, so again, that's graphing our quadratics. All right, guys, the last thing that I want to talk about with this lesson is using our graph to solve a quadratic. So one thing that we saw with factoring was that when we had that equal sign, we knew that's when we had to figure out, okay, x is equal to this specific number. So another way, instead of factoring, that we can solve that is by graphing. Again, why we had set that equal to 0. So for example, we had maybe a problem, let's say like this. X squared minus 4 is equal to 0. And we said, okay, this was difference of squares, if you guys remember. Hopefully you do. But difference of squares being those two terms. And they're both perfect squares. And so remember how we broke that up. We said that was x and x. Square root of 4 was 2 and 2. And then again, we knew that they had those opposite signs in between because, again, that middle sign canceled out. So again, set that equal to 0. And then again, solving, remember, figuring out what x is equal to. So in this case, x plus 2 is equal to 0. So x equals -2. And x plus 2 is equal to 0. Oh, I'm so sorry. X minus 2 on this one is equal to 0. So x is equal to 2. But again, those were our two answers. And again, what we're looking for specifically when we set it equal to 0 is where is it touching this line? Because this is when x is 0, just like we did in our problems. So on a graph, what you're specifically looking for is where does your parabola touch the x-axis? So for example, if this was my problem, I would have answers here and here. Sometimes, if you guys remember, you might have noticed that we actually had problems that only had one answer. And the reason for that is because that vertex point might be sitting on the x-axis. The last thing that we'll get to eventually, though, is actually when you get no solution. That might look like this. It's when we have a parabola that is not touching that x-axis at all. And so those are the different things that we'll look at. So going back to this problem right here, x squared minus 4 is equal to 0. We actually just graphed it. I'll show you guys right now. So this is what you guys just graphed. You know, take a look at those answers. So we said the answer here is at -2 and +2. And again, reading that graph, it's where is it touching that x-axis? So again, we can see again at +2 and -2, just like when we factored it. So again, graphing is just another way for us to figure out where is it touching that x-axis. All right, guys, in our final example then, we're going to take a look at a problem that asks you to solve by graphing. So again, how you know you need to solve is, again, you'll see that equal sign. What we want to remember about solving, though, is that it needs to be set equal to 0. So again, we want to make sure that we set this equal to 0 because we're looking for where's that graph going to cross our x-axis, again, at 0. So your first step in this problem would be to move that 6 over. So subtract 6 from both sides. So we're really working with 1/2 x squared plus 2x minus 6 is equal to 0. Think about descending order again as you rewrite that, and then remember those terms refer to that A, B, and C here. From there, again, next step is going to be to find where is that center point, so that axis of symmetry. So x is equal to -b over 2a. So in this case, x is equal to -2 over 2 times a, which is 1/2. So you'll get -2 over 1. So your axis of symmetry in this problem is going to be here at -2. All right, so let me go ahead and rewrite that problem so we can see it. What we rewrote it to was 1/2 x squared plus 2x minus 6 is equal to 0. All right, from there, we do want to make our table. Again, we are looking for 5 points, and we know that the axis of symmetry should be here in the middle. So again, from there, I'd probably go -3, -4, and then backwards, -1 and 0. Same idea, you want to go ahead and put our graph in. And then again, what you're going to be doing is you're going to be plugging in those points into that equation to figure out what y is equal to. All right, when we do that, you end up getting here, and I'll go ahead and just fill that in, -6 when you plug it in, -7.5, -8, 7.5 again, and -6. All right, so this graph is going to look like 0, -6, 1 and -7.5, 2 and -8, 3 and -7.5, and then 4 and -6. So that's going to be right here. All right, what's going to happen, you'll notice, is that you are going to start to get kind of this curved shape. So something like this. All right, what I want to remind you guys, though, is what you're specifically looking for is where is the graph crossing this point? So in the case that you just graphed your graph like mine, you're going to want to extend your graph, though. So again, that it's going through that x-axis. So something like this. So again, we want it to touch the x-axis, and you're looking for where does it touch? So in this case, like this. All right, one of the flaws with graphing, though, as you saw here, is it's not exact. So in this case, you're going to want to do your best to estimate. So for my answer here, it does look like it's going through the point 2 and the point 6, or I should say -2, I'm sorry, -2, and then also at the point 6. So these would be, again, what's called solutions, or you might hear them referred to as roots, or sometimes even zeros. But these would be my answers. So again, it would be at -2 and -6. Now, in the case that you are unsure, so again, my graph, it's kind of hard to tell. It wasn't exact. What I would like you guys to do is to approximate for me then. So tell me it's about -2, about +6 if your graph is unsure. If it's between two numbers, that's okay. Maybe it's about 2.5, maybe it's about 3.5. But again, use that about sign and then estimate what numbers it's between. So again, that is one of the flaws with graphing, is that it's not precise at times. But again, it does give you an estimate. So again, that's one way that we can solve our quadratic. All right, hopefully that helps, guys. Like I said, if you have any questions, feel free to comment them. Likewise, just email me and I will always happy to help you. I'm going to go ahead and post the homework for this week. Check those assignments also. You guys have till the end of the week to get them in. But again, try your best. Right now, what you're doing is just practicing your graphing, get those U shapes going. And then also, we're going to practice solving. So just like we did in this problem, you're looking specifically where are your graph, or where is your graph touching that x-axis, and again, extend it if necessary. All right, guys, please stay tuned. Make sure to follow the YouTube channel. Make sure to like and subscribe down there. If you have comments or questions, likewise, post them down there for us. We'll see you guys soon.